All right, let's look more at parallel and perpendicular lines. So a few definitions and theorems in this lesson. Perpendicular lines are lines that intersect and form right angles. So we see in our diagram that we have two lines that are perpendicular to one another. Theorem 3.9 says if two lines are parallel to the same line, then they are parallel to each other. So in our diagram, these arrows here tell me that the lines are parallel to one another. Since we used one arrow to indicate that they are parallel to each other, the double arrows tell me that line B is parallel to line C. And also with notation, we would use two vertical bars. Say line A is parallel to line B. Theorem 3.10 says, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So it says if M is perpendicular to T, and we're using this upside down capital T to represent perpendicular, and N is perpendicular to T, then M is parallel to N. And on our diagram, we see when we have a right angle, that means that they're perpendicular to one another. And again, when we see these arrows, it means that the two lines are parallel. Theorem 3.11 says in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So if G is parallel to H and G is perpendicular to F, then H is also perpendicular to F. Okay, we're going to look at an example where we determine the relationship between A and D. And for these, sometimes it helps to draw a diagram. So in the first one, we have that A is parallel to B. So I'm going to draw that. And B is parallel to C. And C is perpendicular to D. So that means D will intersect C and form a right angle. So how is line A related to line D? Well, A will be perpendicular to D. Okay, in the second one, A is perpendicular to B. B is perpendicular to C. And C is parallel to D. So therefore, A is parallel to D. And the last one, A is perpendicular to B. B is parallel to C. And C is parallel to D. So therefore, A is perpendicular to D. All right, for our last example, we're going to do a mini proof. It says that we are given in a plane, A is perpendicular to S, C is perpendicular to S, and A is parallel to B. And we want to prove that C is also parallel to B. So recalling the theorems we just went over, first in our statements column we're going to put what we are given. So we were given that A is perpendicular to S, C is perpendicular to S, and A is parallel to B. And my reason is that those things were given. Now, since A is perpendicular to S and C is also perpendicular to S, so these first two things, then we can say that A is parallel to C because two lines perpendicular to the same line are going to be parallel to each other. Oops. Okay, so therefore C will also be parallel to B since A is parallel to B. Again, two lines parallel to the same line are parallel to one another. All right, and that concludes our lesson.